So question 1, find probability of tossing a coin 5 and getting at least one head. So probability of at least one head. And we look at the opposite of that, because we know that the opposite of that is the probability of 0 heads. And how can we get 0 heads? Well, the only way is with a tail on the first toss, a tail on the second toss, and a tail on the third toss, a tail on the fourth toss, and we know that the probability of each of these is a half. So it's a half times a half times a half times a half, which is 1 over 16. So we know that the probability of at least one will be equal to 1 minus the probability of 0 heads. And we've just worked that out to be 1 over 16, so it's 1 minus 1 over 16, which equals 15 over 16. So question 2 talks about the probability of rolling a dice and getting a sum of 9 or above. So imagine we've got 2 dice, a red and a blue. So to get 9, it could be a 4 and a 5, or a 5 and a 4, a 3 and a 6, or a 6 and a 3. That's to get 9. And of course then with 9 or above could be a 10. So 4 and a 6, 6 and a 4, or a 5 and a 5. They would be the 10s. And of course next we've got 11, which would be 6 and a 5, a 5 and a 6, that would be the 11s. And the last one we've got is a 6 and a 6, which will be the 12. So altogether, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ways. So the probability of 9 or above will equal 10 over 36. So question 3, what's the probability of selecting a blue marble from 5 red, 3 blue, and 2 green? So the probability of selecting a blue is going to equal the number of blues, which is 3, divided by the number of balls altogether, 3 over 10, so 0.3, which equals 30%. So if you roll a six-sided dice, six-sided dice twice, it's probably to get the sum of the prime numbers. So the prime numbers are 2, 3, 5, 7, and 11. So 2, 3, 5, 7, 11. So how many ways can we get 2? We know that that happens once. 3 can happen twice. 5 happens 4 times. 7 happens 6 times. And 11 is twice. So therefore, if we add all those up, 1 plus 2 plus 4 plus 6 plus 2 is 8, 12, 15 out of 36 ways we could roll 2 dice and get a prime number. Question 8, bag contains 4 red, 6 blue. Bag A, bag B contains 7 red. So we've got to do this in 2 stages here. We're going to say bag A first. So what's the probability of a red ball, red marble, from bag A? So we know the probability of selecting bag A is 1 over 2, because there's 2 bags. And then we know there's 4 red marbles in bag A, and there's 6 altogether. So that's 6, 4 out of 10 to get a red one there. So that is 4 out of 20 to get a red one out of to get a red ball out of bag A. And then bag B, the probability of red given, and we choose bag B, equals 1 over 2 for it being bag B. And then if we look at bag, sorry about this, and bag B has 7 of them are red, so it's going to be 7 out of 10. And that equals 7 out of 20. So the probability of getting a red ball from either bag is going to be 4 out of 10, 4 out of 20, sorry, plus 7 out of 20. Because it can come from either bag, which is 11 out of 20, which I think is 0.55 or 55%. Flip a fair coin and roll a sift, so it's number 9 now we're on. You flip a fair coin and roll a fair 6-sided dice, probability of getting a head. So the probability of a head and an even number. So the head followed by an even number. So the probability of a head we know is 1 over 2. We know there's 3 even numbers on a dice and 6 numbers altogether. So basically it's 1 over 2 times 1 over 2. Because 3 over 6 is 1 over 2, so 25%. Question 10, box contains 5 red, 3 blue, so 5 red, 3 blue, and 2 green. And this says the probability of getting 1 red and 1 blue. Now we've got to do this twice because we've got to do probability of red-blue, or the probability of blue-red, because that could either of those would count for this, because the question says 1 red and 1 blue. It doesn't talk about order, so we've got to do both of these equations here. And if we do the probability of red first, well, there's 5 red and there's 10 altogether, so it's 5 over 10. And if we want blue next, we know there's 3 blue, but only 9 left now because we've got without replacement. If you read the question, without replacement means that now we've got 9 balls left. Next one, we want blue-red. We know there's 3 blue and 10 altogether. When we take that blue one away, we're looking for the probability of red. So it's 5 red out of 9. We multiply all these together, so 15 out of 90. there and 15 and a 90 there. So it's actually the same thing. And we add them together because we actually don't worry which one we've got. So your final answer, probability of red and blue, equals 30 over 90, because we had 15 over 90 plus 15 over 90, which is 33.3%, 1/3. Just consider the question 11 now. Consider the word probability. I think it's got 11 letters. And it says, what's the probability of selecting a letter and it being a vowel? So we know we've got a vowel in the O, the vowel in the A, the vowel in the I, the vowel in the I. Y is not a vowel. So what's the probability of selecting and getting a vowel? So it's the number of vowels, which is 4. Although there's two I's, it doesn't matter. And there's 11 altogether, so 44%. Question 12, a committee. 4 members, we're looking for 4 members to be chosen, so everything's probably going to be choose. Committee questions are usually combinations. What's probably the committee will be composed entirely of doctors, so probability of doctors only. Now, how many doctors have we got? Well, we've got 6 doctors. So we've got 6 doctors, and we're going to choose 4 of them, any 4 of them. So 6 choose 4, and we know there's 13 people altogether. So the selection was totally random, be 13 choose 4. And that answer is 0.02, which equals 2%. Question 13. Game of poker, so we're looking for a 5 spade flush. Here it says a flush, all of 5 cards. So we know that probability of spade flush. We know there are 13 spades, there's 13 of every suit, and we're looking for any 5 of those, so 13 choose 5. Now, how many ways can we take 5 cards from 52 altogether? It was 52 choose 5. And that answer is 0.00049, which if we move the decimal place along 2, we get 0.049%, really small. Question 14 talks about a test. So we know the probability of, we're looking for the probability that neither test shows steroids are present. So they both could be negative tests, basically. So we want the probability of negative on test A, which has a 93% success rate, times the probability of negative on test B, and test B is 87% successful. So the probability of test A being a negative is going to be 100% minus 93, which is 0.07. So that's 100, basically 1 minus 0.93. And then times the probability that test B is negative, well, that's going to be 0.13, because it's going to be 1 minus 0.87. Okay, we're using this number here and that number there into decimals. So 0.07 times 0.13 equals 0.0091, which equals, move the decimal place along 2, 1, 2, equals 0.91%. So question 15 is similar to a Venn diagram. Let's just draw a Venn diagram here. So we know there's 2 circles, to put a red and a blue one. Of course, I could have done that better, couldn't I? Let's Go back and do that again. And I'll put the blue one like that. Perfect. Okay. So we know that 32% of the property listed to rock and 26 to country. 9% listen to both. So we're going to put 9 in the middle. Let's make this one rock. And this one country. So rock is 32, so we do 32 minus 9, we get 23 in there. And we know that 26 is new country, and 26 times 9 is 17. So we've got 17 in there. And the question says, what is the probability that a student listens to neither station? So we've got to add all these numbers up. 23 plus 17 is 40, plus 9 is 49. That means there's 51% of the people are outside. So the probability of neither equals 51%.